Hello everyone, we're going to do some mole, mass, and particle problems today, and I'm going to be making this video for you, and I'm going to be doing the odd ones. So you're going to be responsible for doing the evens, and you're going to be wanting to do them exactly or very similar to the same fashion that I'm going to be doing these myself as I do the odd ones, okay? So anyway, let's go ahead and get started on one of them. The first one is how many formula units, hold on, let's get this one here. How many formula units are there in 24 grams of FeF3? Okay, in order to get this set up, the first thing I want to do is find out what I have. And I'm just going to go ahead and circle what I have. I have 24 grams of FeF3. And then on this, how many formula units? Well, I guess I would underline that. So let's just make it a different color so that we show that we underline it. I would underline this, how many formula units, and I would put a question mark underneath that. This is where I am, 24 grams, and this is where I'm going, how many formula units. So let's go ahead and set this up here. You always start with what you're given. So 24 grams, come on now. Let's see if we can get it going. Why is it not working? Come on. I suddenly can't get anything to work. Oh no. Come on. What's going on here? It's not working. 24 grams. So apparently my Apple Pencil's not working. It may have unpaired itself. So let me see if I can pair it back up here real fast. Okay, let's try again. 24 grams of FeF3. I think it must have just unpaired itself. I'm going to draw my lines. Now I'm going to need to go from, and just kind of make my plan over here, I'm going to have to go from grams to moles, because we always have to go into moles. And then from there I'm going to go into particles. Well, how do I get from one to the other? Well, if I go from grams to moles, I'm going to have to use molar mass. Right? Okay, we have to have molar mass in order to get from grams to moles. And then to get from moles to particles, I'm going to have to know Avogadro's number. Okay, so I'm going to have to know that to go from moles to particles. Well, let's see. We need to do molar mass first of all. Well, the molar mass of FeF3, well, let's see. I believe, and I don't have, let me pull up a P table real fast. I don't have my P table up yet. So let's go ptable.com. There we go. I don't have a periodic table with me here. So instead I'm going to have to just do it on the fly. So there we go, ptable.com, pull it up. There we go. Okay, so iron has a mass of 56, okay? So if I do my molar mass over here at the side, Fe has a mass of 56, and I need one of them. Okay, so that works. And F has a mass of, let's see, 19. Have 19, and I need 3 of those. Okay. Well, let me see. Let me grab my phone, because it's going to have a calculator on it somewhere. Oh, I need all my technology. Where's my phone? There it is. My bad. My phone got lost. Let me come back over here and get it. Sorry about that, everybody. Okay, so my phone has a calculator on it, so I'm going to use that. It's not the best calculator, but it'll be fine for now. I'm going to take 3 times 19 equals plus 56 equals, and that's going to give me 113 grams per mole. So that's going to be 113 grams per mole. And then I can use that on here. And I'm going to put the 113 grams underneath and 1 mole on top. Grams are going to cancel. They're gone. Bye-bye. And now I'm into moles, and not just any moles, I'm into moles of FeF3, okay? So now we need to go from moles into particles. So I need to go from moles into particles, and I just lost my pairing again. We're having technology issues today like crazy. Come on now, pair in here for me. My Apple Pencil is being a monster. It probably needs to be charged now that I think about it. Okay, so now I'm going to put 1 mole on the bottom, and I'm going to put 6.02 times 10 to the 23rd particles on top. And let me erase a bunch of this out of the way because it's taking up too much space. There we go. Get that all out of the way. I know I didn't get every little particle, but that's fine. And what is that going to equal when it's all said and done? Well, on your calculator, you want to put it in like this. 24 times 6.02, and then that EE key, remember that? Do the EE key, 23, and then divide by 113, and then the equal button. So that's how you would actually punch that into a calculator. And when you do, you're going to get the answer. And the answer, hold on here, let me get it for you. On my calculator, it's going to be 1.3 times 10 to the 23rd particles of FeCl, or FeF, not Cl, FeF3. And that would be your answer, okay? So now you're going to do number 2. I'm going to move on down and do number 3, and I'm going to try to do all the odd ones for you and try to get them done as quickly as I can so that you don't have to watch this video for too long. But here we go. Let's do this one. How many grams are there? And again, I'm going to need to underline what I don't have, right? So I'm going to underline grams, and that's going to be question mark grams. Are there in 2.3 atoms of silver? Okay, so I have 2.3 atoms, and I want to find grams. So in other words, I'm going from particles to moles to grams. Okay, so that's our plan. So let's write down what we're given. We're given 2.3 times 10 to the 24th atoms. And atoms are a form of particles, so that's just fine. And not just any atoms, it's atoms of Ag. Okay? Now, what is the molar mass of Ag? Because that's the next thing that I'm going to have to do. I have to get from grams into moles. And when I look on my periodic table, I see that silver has a mass of 108 grams per mole. So I'm going to put 1 mole of Ag. Oh, wait a minute. We have to go from, not from there to there. Brain fart. We're going to have to go from atoms into moles. So I know that there are 6.02 times 10 to the 23rd atoms of Ag in every 1 mole of Ag. Okay, so there's that. And then the next thing I want to do is I want to go from 1 mole of Ag to 108 grams of Ag. Okay, so that's going to be my last step because I go from particles to moles and then from moles to grams. So if I were to punch this into my calculator, it would look like this. It would be 2.3, my EE key, EE24, times 108 divide by 6.02 EE23 equal button. And if I were to do that, I would get my answer. So let me pull up my answer here real fast. And it looks as if I'm going to be at 4.1 See, 4.1 times 10 to the second grams of Ag. Or I could say 4100 grams of Ag. So you could say either way, okay? And that would be my answer to number 3. All right, hopefully you guys are catching on. Let's go ahead and let's look at number 5. And I'm just kind of plugging along here, trying to get them all done. Number 5, it says, how many grams are there in 7.5 times 10 to the 23rd molecules of sulfuric acid? This is H2SO4 is sulfuric acid. So again, if I were to underline what I don't have, it's doing it again. My eye pencil, or my Apple Pencil, I guess. It keeps unpairing. That's very frustrating. Hold on just a second here. Let's let that pair. So, can you do it right?
Did you set it today?
No, we're good. We're good.
Okay, thank you.
All right, housekeeping is knocking on the door. I'm back. Okay, let's try this Apple Pencil one more time. How many grams are there? So I'm going to underline grams and put question mark on grams. And then I'm going to circle what I have. What do I have? I have 7.5 times 10 to the 23rd molecules. So let's look at our plan. Our plan is to go from molecules to moles to grams. Well, how do you get from molecules to moles? Well, to do that, you have to use Avogadro's number. Avogadro's number, and I spelled it kind of wrong. And then to get from moles to grams, you have to use molar mass. Okay? So let's try it. I'm going to go ahead and erase this so that we can go ahead and set up our problem. So here we go. I'm going to start with 7.5 times 10 to the 23rd molecules of H2SO4, or sulfuric acid. And I'm going to draw my lines. And let's see, I need to use Avogadro's number. So let's try that. 6.02 times 10 to the 23rd molecules of H2SO4 is the same as 1 mole of H2SO4. So look at that. The molecules are going to cancel and I'm left with moles of H2SO4. But I have to go one more step. I have to go with molar mass. Well, let's see. What is the molar mass of H2SO4? We don't have that yet, do we? We have 1 mole of H2SO4, and I need the grams of H2SO4. Well, that's going to be, let's see, H, and then S and O. There's going to be 2 of these, and each one of them is going to be 1 gram. There's going to be 1 sulfur, and every sulfur is 32 grams. And there's going to be 4 oxygens, and each one of those is 16 grams. So let's do some math here on the calculator. And that's going to be 4 times 16 plus 32 plus 2. That gives me 98 grams per mole. So I'm going to write 98 grams of H2SO4 up here. Moles are going to cancel, and I'm going to be left with my answer. All right? And I'm going to put that answer on here in just a second. Let me erase my molar mass calculation. Get that out of the way. And we're going to come back over here. And when I put everything into my calculator, if I were to actually write that out, it would be 7.5 EE23 times 98 divide by, sorry, my finger is touching the screen and it's causing it to divide by 6.02 EE23 equal button. And that is going to be 1.2 1.2 times 10 to the second grams, or you could say 1200 grams H2SO4. Okay, so either one of those would work just fine. All right, hopefully you guys are doing okay and you're tracking with me on these. We do have some more to do. I'm going to go ahead and do the next one, which would be number 7. How many grams are there in 9.4 times 10 to the 23rd molecules of H2? Well, again, I'm going to circle what I have, which is 9.4 times 10 to the 21st, or 25th. And I'm going to underline and question mark where I need to go. So without going through the map again, we see that we're going from grams to moles to molecules, okay? So I'm going to start with molecules and head to grams. So here we go. 9.4 times 10 to the 25th molecules of H2. And I need to get from molecules of H2 into grams of H2. Well, let's get out of molecules and into moles. To do that, I need Avogadro's number. 6.02 times 10 to the 23rd molecules of H2 is the same as 1 mole of H2. Okay, so molecules canceled, and I'm left with moles. Now let's go from moles into grams. Well, I know that 1 mole of H2, or hydrogen gas, is going to have a mass of 2 grams of H2. So moles are going to cancel, and I'm left with 2 grams. If I were to put this into my calculator, it would be 9.4 EE25 times 2 divided by 6.02 EE23. And if I were to do that, I would end up with 3.1 times 10 to the second grams of H2, or I could say 3100 grams of H2. Okay? So, is that right? 3.1? Yeah. No. It would just be 3100 or 310. Dumb. Okay. So that would be 310 grams of H2. You know what? I did that wrong up here too, didn't I? Yeah, this is not 1200. This would be 120. Did you do that up here too? I did. Wow. Gee whiz. I need to be back home, don't I? It's Washington, D.C. is making me lose my mind. Okay, so there's that. You're going to be doing problems 2, 4, 6, and 8. Now let's go to the next page, trying to cruise through these as fast as I can. And let's see, I'll do a few more here. I know I'm going to be running out of time soon. This is on a 20-minute timer, so it won't let me do anything after 20 minutes. So let's do this one. We've got 2.3 grams of ammonium sulfite, and let's see, how many formula units? So I need formula units on this side. So let's set it up. We've got 2.3 grams of NH4SO2. And I want to get into formula units, okay? So let's see, I know that I need to get into molar mass first of all. So let's see, what do we know about this? This is going to be, there's some N, there's some H, there's some S, and there's some O. Let's see, there's 1 nitrogen and it's 14. There's 4 hydrogens, 4 times 1 of those. There's 1 sulfur, and that's 32. And there's 2 oxygens, and there's 16. So let's add that up to get that molar mass here. How am I going to do that? That's going to be 16 times 2 equals plus 32 plus 4 plus 14. That gives me 82. So this is 82 grams per mole. So let's put that in here. I put 82 grams on the bottom, and I put 1 mole on the top. The reason why I put the grams on the bottom is because